All right. Okay, well, welcome once again. My name is Dave Nadler. I'm the warning coordination meteorologist here at the National Weather Service in Peachtree City, Atlanta. And we are going in our first session. This is a part of our integrated warning team workshop, partners workshop. Usually we do these in person in Atlanta. Unfortunately, given the circumstances around COVID, we're unable to do that this year, but we definitely wanted to put some things together. So this is this session this morning is sort of like part one of a three-part workshop throughout the day today. So this morning that we're going to get into is going to discuss the winter outlook and some of the things we might be able to anticipate across the state throughout the next few months. The next session, which starts at 11 a.m., will be more talking about useful tools and resources to help you with situational awareness, preparedness when it comes to higher impact weather related activities. And then the third session this afternoon is going to be about like a scenario, a simulation, a winter weather simulation that we're going to go through. Adam Baker, one of our senior forecasters, and myself will be tag teaming that, and that's at 1:30 this afternoon. So we really appreciate those of you that were able to take the time this morning to join us, and we'll go ahead and get started with the winter outlook as we're already into December. One of the things, and if you've seen me do a presentation on winter outlooks before in the past, I like to sort of throw up this disclaimer slide about 90-day outlooks, in just the sense that they are longer range outlooks and they don't get into the finer details of what actually could happen. So I always kind of throw that out there. It provides like a big picture view of a longer period. We're talking about, multiple months. What these outlooks do not do is they do not tell us how many winter events we're going to get, throughout the season. They certainly don't tell us that it's going to snow 3 inches on Christmas Day, or that we could have a record cold outbreak in January or February, or even like an early spring type thing. So they are designed to give us an idea of what to prepare for, but I think we can provide some context and detail to some of the contributors to each winter season across this part of the country, and we're going to try to do that in this session this morning. So here it is. You've probably seen this. This was actually released from NOAA back in mid-October, so not a whole lot of change. They haven't made any updates, and this is a 90-day outlook for December, January, and February. So what you're seeing on the graphs is a temperature outlook on the left and a precipitation outlook on the right. So you probably heard us talk about El Nino and La Nina, the ENSO patterns. Well, we're actually in what's called a moderate La Nina pattern right now, and that's expected to continue through the winter and into much of the spring next year. So what that typically means, and again, we're just talking about the La Nina El Nino patterns. When we are in a La Nina winter, all it does is basically says that it increases the chances of seeing drier than normal and warmer than normal conditions over that 90-day period. So again, as I mentioned earlier, it doesn't necessarily say that, in mid-January we could have record cold. It's not pointing at things like that. It's looking over the course of 3 months. So that's why I show these outlooks, and when you do see them, please take it with a grain of salt, because it doesn't mean we're going to have a warm, dry winter. It just means that the chances of seeing warmer than normal conditions or drier than normal conditions over that 90-day period are a little bit higher than normal given the La Nina influence. Speaking of La Nina, you'll see that we've had 7 La Nina winters since 2000, 2001, and the last La Nina that we had was actually 3 years ago, 2017, 2018. We'll talk a little about that here in just a second. So looking back, and this is just since about 2000, so in the last 20 years, what are some highlights when we are going into winter with a La Nina pattern? Well, in 2010, 2011, which was a La Nina event or period, we had the 5th snowiest winter on record at Atlanta. And in Athens, it happened to be the all-time highest snowfall season back in 2010, 2011. The next year in 2011 and to late 2011 into 2012, it was the number 11 all-time snowiest season in Atlanta. You may think it's probably not that much, and we'll go into that here in just a second. But over the course of 120 plus years of records in Atlanta, to be in the top 10 or 11 is pretty noteworthy. Back in 2008 and 2009, it happened to be the third snowiest winter in Columbus, Georgia. So again, just to point that out. So that's snow, a couple of highlights for snow. What about ice events? And I know a lot of you that you hate to hear that word because certainly can create a lot more problems than snow for obvious reasons. But with ice events, and we really haven't had a significant, widespread ice event in a few years. But with La Nina patterns, unfortunately, it does increase the potential to see ice events. And we'll talk about a little bit more about that later in this session about how things come together to support freezing rain and ice. We cannot forget about severe weather during the winter season and heavy rain and flash flooding because despite the potential for snow and ice events, we definitely can run the risk throughout the winter time, especially as we head into the end of January and through February and early March of seeing more significant widespread severe weather events. So a couple of dates there that you see during La Nina winters back in 2011 and 2009 from 06 to 08. So pretty much every winter, especially with La Nina periods, we see sort of an increased potential of seeing severe weather across the state. So that's definitely something to not forget about, even though we are heading into the colder months of the year, especially for parts of middle and south Georgia. The threat for severe weather will exist with some of these more significant storm systems that impact the area. Okay, I thought I'd put together some fun facts for everybody as we're talking about the outlook here before we get into a little bit more detail. But for the Atlanta area, I kind of put this question: what is the average number of days that we see the minimum temperature at or below 32 degrees? So basically, nighttime temperatures below freezing. And keep in mind, these are calendar year numbers. So I'm not just looking at December, January, and February. I'm basically looking from January 1st all the way through December 31st. So, and this is just, I break it down for Atlanta, Macon, Columbus, and Athens because those are our 4 official climate sites. But starting off at Atlanta, we average 42 of these below freezing days or nights throughout the year. And 33 of those occur in the months of December, January, and February, which is our climatological winter period, that 90-day period. Doesn't mean we can't obviously get winter weather in November, March, or even April, but we're just looking at the 3-month period here. So 42 for the entire calendar year is average. 33 for the months of December, 33 of those 42 occur in December, January, and February. So a pretty high number, about more than 75%. Here's the record number, and then this is going back to, for Atlanta, statistics go back into the late 1870s, early 1880s. 88 number of below freezing nights or days for a calendar year back in 1968. So pretty good number there. 1968 was a very cold winter. I was not around for that, thankfully. What was the lowest number of below freezing days? 13, and actually happens to be this year through December 9th. So we are on pace. If we don't see any more days or nights below 32, which I doubt that will happen in the next 3 weeks, but we're at 13. That would be the new lowest record throughout a calendar year. The next lowest happens to be 18. So if we see less than 5 more days in Atlanta of 32 degrees or less officially at the airport there, it would tie the record, which was also set back in 2012, 1990, and 1921. How many were last year, calendar year? There were 19 days. So again, well below the average of 42. Last couple of years, last couple of winters have been fairly mild. And then the last La Nina winter we had, which was December, January, and February, 2017, 2018, we actually had 31 days that were at or below 32 degrees or nights. So just to put that in perspective for temperatures, just to throw that out there. What about snowfall? So here are the top 12 snowiest seasons in Atlanta. The blue boxes that you see with the years are actually La Nina winters. So 2 of the top 12, and this is only going back to 2000, 2 of the top 12 happen to be in La Nina winters are in there for Atlanta. So back in 2010, 2011, and 2017, 2018. The numbers aren't overly impressive. You see in the top 12, like number 10, 11, and 12 is less than 5 inches of snow. This is at the airport. Keep in mind, parts of like Northwest Metro can certainly, North and Northwest Metro can see double or triple these amounts sometimes. We've seen that those numbers vary quite a bit from north to south across the Metro Atlanta area. But just to kind of put it, these are official records from the airport. Okay, so what about Macon? Now that you've seen everything, I'm not going to go like line by line, but in Macon, for those of you that are in that area, the average number of days were calendar days at or below 32, 38. The record number is 89 in that same year, 1968. The lowest number was 11 back in 1921. The next lowest would be 17 in 1949. And last year, actually, Macon had 33 days at or below 32, which was far surpassed Atlanta. So to give that kind of perspective there. So are we doing okay on questions? Anything pressing before I continue? Okay, awesome. Snowfall top, this is just a top 10. In Macon, none of the top 10 were in the La Nina period, at least since 2000. I haven't looked back at all those years, but just recent periods in the last 20 years or so, no La Nina winters fall into the top 10 snowfall for Macon. Here's Athens, and I mentioned this earlier, when you take a quick look at the snowfall records, the year of 2010, 2011, where Athens got officially 13.6 inches of snow, was a La Nina winter and happens to be #1 all time. And these records go back into the early 1900s. So we're not just looking at 30 years of data, we're looking at over 100 years of data for all 4 of these stations. With temperatures, again, at or below 32 degrees, the average number for Athens over a calendar year is 48. The record is 84, and the lowest number is 17, which happens to, again, be this year. The next lowest is 24. So if Athens sees less than, 6 more days at or below 32 through the end of this year, it would be a new low for 32-degree periods or days over the course of a calendar year. And then finally, here's Columbus. See the numbers there for Columbus with the temperatures, and again for the snowfall. 2 of the top 10 snowiest winters for Columbus came from a La Nina winter, which is what we are headed into. You can again take all of this with a grain of salt, just throwing numbers out there for you so you can put some context and perspective into what we could see heading into this winter. And again, one final thing for numbers, just for fun. Many of you may recall what happened 3 years ago, the last time we actually had a La Nina period heading into winter. And it was this heavy snow event that we had in early December. A little bit more than 3 years to the day. It was December 8th of 2017, where parts of west central into North Georgia saw anywhere from like 6 to 12 inches of snow with isolated higher amounts over a foot. That was a very unusual event in the sense it was early season, but also the duration of precipitation, snow that we had during the day, no least. It was a very impressive event. A lot of energy, a lot of moisture, Arctic cold air in place, and as a result, we had some significant heavy wet snow across parts of the area with that particular event. One thing to keep in mind before we move forward, regardless of any outlook that you see, really, we always have to be prepared. I know you hear us talk about that for anything. It doesn't have to be just weather. We have to be prepared for higher impact, significant weather events throughout the year. So don't hang on, a 90-day outlook to make you believe that it's going to be like a warm, dry winter and we have nothing to worry about. A lot of the times, what we've also seen with La Nina winters is that we may be overall warmer and drier, but we see more extremes of warmer, much warmer than normal periods and much colder than normal periods. And it really only takes one system to develop, like in the Gulf of Mexico, and move up across the area with cold air in place to create some problems related to winter weather across the state. Okay, let's move forward. We're doing good on questions so far? Oh. Yeah, I mentioned that earlier. This being recorded, we're also going to, keep the slides together for everyone to see following the session as well. Absolutely. Okay, what are some of the potential contributors to our winter season? We've already kind of talked about El Nino, La Nina. Also want to get into a real basic sense of what the Arctic, some of these pressure patterns, Arctic oscillation and the North Atlantic oscillation. And again, climatology, which is like looking at what has happened historically in the past. So, yeah. All right. So looking ahead, this is, or looking at the ENSO pattern, which is El Nino and La Nina. As I mentioned earlier, we are in a La Nina period right now. So what you see is with La Nina, we're looking at several portions or areas of the Pacific Ocean where they measure sea surface temperatures. And if these sea surface temperature anomalies are below normal, that's what's considered La Nina. And if it's El Nino, it's the reverse. The sea surface temperatures are warmer than normal and above that 0 degree line. So basically, we're kind of, what you see is we're over here, in that -1 to -1.5 degrees Celsius below normal for those areas in the Pacific Ocean right now. And you can see we'll continue to see over that. What you're seeing at the bottom is a 3-month, like October, and then it goes to OND, means October, November, December. So it's looking at a 3-month average, and then it measures. So we don't quite have that 3-month average yet beyond October for official measurements, but that should be coming shortly. November, December, January is NDJ, and then of course moving forward, December, January, February, which is our climatological winter. You can see that these are all different models that measure El Nino and La Nina, the sea surface temperature of the Pacific. Just about every single one of these reliable models for measuring sea surface temperatures out there are running in that La Nina phase. So that kind of takes us to the next slide here. Basically looking at the bars here over on the far left, we are basically at all the blue bars you see are La Nina. So from October, November, December, all the way through the winter into early next spring, we run a very high probability of remaining at La Nina sort of levels over the next 3 to 6 months. So as you look farther out into the year, next year, you see some of those gray bars start popping up. That means neutral conditions, and then the small red bars at the very end of next year start to creep up into El Nino a little bit, but it's a very low probability, and that's way out into the future. So the probabilistic stuff is certainly going to change over time. So you can pretty much bet we'll stay La Nina over the next few months through the winter into early spring. So what about this? What is this Arctic oscillation? Well, I'm going to talk about the Arctic oscillation and the North Atlantic oscillations. These have more shorter term influences on our weather, about a 2 to 3 week forecast or outlook. So we're not looking at like, El Nino, which is more like a 3-month kind of periodic outlook. This is a little bit shorter term. So what the Arctic oscillation, it's all related to pressure, the pressure across the entire Earth, the entire atmosphere. So when we're talking about I know you guys have heard the term polar vortex. There is always a polar low or a polar vortex that exists in the Arctic or polar regions. Now, when that low is really strong and powerful with its pressure, the polar jet stream up there usually stays pretty compact, okay, and stays north of much of the United States. So that's called a positive phase. When that polar vortex is pretty strong and powerful, it keeps all that cold air bottled up there in the Arctic and northern Canadian region. When the Arctic oscillation goes to what we call a negative phase, and again, we're able to see these phases several weeks out to anticipate whether or not we might get kind of a cold Arctic polar plunge of cold air. When this oscillation goes to a negative phase there on the right side of that graphic, the polar vortex or that polar low weakens. And what that allows the polar jet stream to do is sort of buckle and weaken as well. And that allows some of those Arctic cold air intrusions to move south across parts of the United States and of course parts of the Southeast region. So it's definitely a player every year, especially in the wintertime. So it's something we look at, and we're able to sort of get a feeling for when, if we're let's say we're in a period of very warm, dry weather, but the Arctic oscillation is starting to turn negative in its phase, then over the next few weeks, we could be looking at a colder period of weather moving across the U.S. So this is one tool that we can use. All of this information at the very bottom there, the Climate Prediction Center, it's part of NOAA. They're the ones that actually issue the outlooks, the 7-day outlooks, the 8 to 14-day outlooks, the 3-month outlooks. All of this can be found if you're really interested in seeing where these projected phases might be happening over the next few weeks. All of this is available at the Climate Prediction Center. Okay, So what about the North Atlantic Oscillation? So very similar to the Arctic Oscillation, but it's sort of shifted. Instead of it being over the polar regions in the Arctic, it's more over the North Atlantic region. So you have subtropical high pressure, like the Bermuda High over the middle Atlantic region. And then to the north, farther up in the North Atlantic, you have an area of strong low pressure. This is when the North Atlantic Oscillation is in its positive phase. This is the pattern that we're looking at. And what this does for us typically is keep more of a ridge of high pressure over our area, which usually results in warmer and drier conditions versus colder and more active wet conditions. So if you flip that phase to negative, what happens? Well, that subtropical high weakens. That's kept us warm and dry. And the polar or the North Atlantic area of low pressure weakens as well. So when you have that weakening of low and high pressure over the middle and North Atlantic regions, that allows that polar jet in conjunction with like the Arctic Oscillation to buckle, if you will, and weaken. And some of that cold air from the Arctic polar regions could surge down across parts of the United States. Throw in a storm system or two, and this could result in stronger, higher impact winter storms. So really in a basic sense, didn't want to get too technical or detailed. These are definite shorter range phases and things that factors that we look at to project over the next couple of weeks. Not necessarily whether or not we're going to see snow or ice or heavy rain, but what is the pattern of the temperatures, the overall long wave pattern going to look at in the next couple of weeks. So we're able to look at these things and get at least an idea as to what's going to happen over the next few weeks. Okay, let's talk about, we've done some local studies, and I know the 90-day outlook from CPC for December, January, and February told us that we have a higher probability of seeing warmer than normal temperatures and drier than normal precipitation or conditions throughout that 3-month period. But looking back at La Nina periods over parts of Georgia, what has actually come up since 1950 all the way through 2016 is that we run the highest probability of seeing near normal temperatures over, and this is just looking back at actually what happened during those La Nina periods. So doesn't mean that we're not going to be potentially warmer or drier overall this year, but looking back at past La Nina events, the probabilities are higher for near normal temperatures versus above normal and below normal temperatures. The next highest would be that 35% for above normal temperatures. So that would be the second place there. What about precipitation? Again, based on local studies that we've done looking back here for La Nina winters across parts of Georgia, the averages lean more towards seeing a near normal precipitation pattern over that 3-month period. And then the second highest would be the 35% for a drier than normal precipitation pattern over that 3-month period. So you can see, we have the outlook for this year, but there's a lot of other things that can factor into seeing, closer to normal temperatures and or even closer to normal precipitation over that 3-month period. I know you're all very excited to talk more about ice, so here we are. We definitely run the risk of seeing freezing rain and ice storms across parts of the state, especially the northern half of the state, northeast areas where I know a lot of you up in that northeast Georgia quadrant have heard us talk about what we call cold air damming, or the wedge, which is a wedge of shallow cold air kind of running down the east side of the Appalachians. When you have that set up in place, and then we have what we call overrunning, which is precipitation coming in from like the west or the south over top of that shallow cold air, it usually results in ice storms. We basically have rain that's freezing on contact, and the rain is happening because above that shallow layer of cold air, the temperature is above freezing. So anything that was frozen has enough time to melt into liquid and not enough time to refreeze before hitting the ground. So it stays liquid basically until it reaches the ground on contact and freezes. So this gives you an idea of looking at sort of the atmospheric profile, let's say the lowest 3,000 feet. For freezing rain, you can see that shallow wedge of cold air, it starts off as snow, but there's enough of a warm layer between the ground and the cloud base for that snow to melt to become liquid. And there's not enough, the cold air near the surface is not deep enough to actually refreeze that liquid before making contact with the ground. And that's why we see what we call freezing rain. And of course, that results in ice accumulation. It's very deceiving because it's not white or it's not like sleet or snow. It's basically liquid, but yet you see, the ice starting to accumulate on especially initially trees, power lines, bridges, and overpasses, that are more exposed to the cold air near the surface. Any questions, Sid? We're doing all right there? Okay. We're going to move along here. We're wrapping up, but I do want to mention, and we'll talk more about this when we get into like our products in the next session at 11 a.m. But always keep in mind impacts. We definitely have criteria and thresholds for advisories and warnings based on snow amounts or ice accumulation. But in this case, we have 2 to 3 inches of snow on the ground, but the temperature is sitting at about 34, 35 degrees. And especially with the resources that GDOT has today and some of the public works folks around the area have to brine streets and treat streets around the area, the roads might be just fine. Still could be certainly an impact in certain areas, but not looking at a widespread significant impact with respect to travel when we're running in the mid-30s and it's snowing. However, drop that temperature 5 or 6 degrees into the upper 20s with snowfall or freezing rain. It doesn't matter the amount. We could just see like a light glaze of freezing drizzle or light snow. If that temperature is in the upper 20s to near 30 degrees, the road conditions, again, not treated, could be looking at some serious, significant problems. So those are all things that I know you all keep in mind as things that we address when we do our briefings, that, amounts are important, timing, duration, all that stuff is very important. But when we're talking about winter events, those temperatures are just as critical as the potential duration and amounts of precipitation that we can see during an event. So I'd like to just kind of wrap up by mentioning we talked about severe weather and tornadoes. During La Nina periods, unfortunately, there is a risk, looking back at other La Nina winters into early springs that we've had in the past 40 to 50 years. Not every one of those has been like above normal or more active, but definitely we've seen that we run the risk of seeing more severe weather events across parts of the lower Mississippi Valley into the southeast region during the months of December, January, and February, especially as we head into late January into early February, where we do see more of that clash of air masses, the cold Arctic air to the north and the warm subtropical air coming in from the Gulf of Mexico and the Atlantic. So please keep that in mind. We obviously always hope and pray that we don't have any major, tornado outbreaks across the area, but we unfortunately live in a region where we do have these from one year to the next. It's just really it's not so matter of if, more when. So keep that in mind heading through the winter into early spring, that, we can, during a La Nina period, we can run the risk to see more of these severe weather and tornadic events. Okay, that is just going to wrap up real fast. Earlier we showed the outlook. This is the 90-day outlook from Climate Prediction Center, NOAA, showing the temperatures on the left, precipitation on the right. Again, these are just probabilities. So during a La Nina period, which is what we're in right now, a moderate to almost strong La Nina right now heading into the winter, that typically results, again, across parts of the southeast region, of a higher chance of seeing above normal temperatures and a higher chance of seeing below normal precipitation. However, if you recall our local climatology studies that we did, the highest probability across the state of Georgia were right around normal to see near normal temperatures and near normal precipitation. Again, regardless of these outlooks, it doesn't tell us, how many snow or ice events we were going to have throughout that 3-month period. It certainly doesn't tell us how cold it can get in mid-January, or if we're going to see record warmth or anything like that through the period. So again, it's just a 90-day outlook. And the last La Nina winter that we had was 3 years ago. And we did have that big event early in the season. And I think we had another event in mid-January. It was a snow event for much of the area, actually, in 2018. And again, I already talked about that. Regardless of outlooks, always have to be prepared for winter weather across these parts, especially the northern half of the state. But, it's certainly not out of the question for parts of middle and even South Georgia to experience a snow event or an ice event from time to time. Okay, well, that wraps up our session this morning. Certainly we'll take some questions. Before we do that, I'm going to go ahead and stop the recording.